Thank you. All right, again, thanks for joining us. This was originally set up kind of as a one-on-one between me and the new HISC planner, Jack, who is here in the room. I'm Christy Martin with the coordinating group on Alien Pest Species, and just wanted to open this up to anybody who wanted to join. You know, some of it's going to be really remedial for some of you folks are true experts in, first of all, natural history. We are going to get more into, at some point in the presentation, we're going to get more into some of the framework of our biosecurity program. And so we're going to have some opportunity to dig in and ask questions about different parts of that framework and what it looks like and maybe where we need to focus. So with that in mind, feel free to go ahead and unmute and ask questions if you would like. We'll also save a lot of time at the end for questions. All right, but first of all, the title slide is always kind of fun to talk about. The image on the left is the airline tracking for a year worth of time. And it just shows our real connectivity with all sorts of areas in the US. And the line on the right, or the image on the right, is from a NOAA data set, and that shows shipping tracking lines. I just wanted to point out, we have some level of connectivity with the Caribbean through the Panama Canal, and that's been an issue for us. We'll talk maybe just a little bit about what one of those recent issues. It is real, that connectivity is still there. All right, so a short little outline. We're going to talk about natural history of Hawaii and colonization. If you are an expert in this, feel free to mute yourself, or sorry, mute me. We'll talk about prevention and control, the framework, all in one slide. And we'll talk a little bit about terrestrial and aquatic pathways, but we're going to do this by talking about top 5. What are my top 5 issues? And that way we'll talk about some of the pathways in there. And if you're taking notes, you don't need to. You can have this presentation. Some of the notes for it are in the comments that you can't see on the slide, but you'll be able to see it when you get the PowerPoint. What can we do? And then, of course, a Q&A.
Can I jump in with a question?
Absolutely, Jack. Go ahead.
Yeah. Thank you. So, Chelsea, put your name, and I was just wondering if you could give a little bit of background about yourself and CDAPS, because, right, so Chelsea set this up to talk to you, and I also wanted to say, I don't know if Josh Atwood is listening, but when I first told Josh Atwood that I had switched over from Kubu into HISC, yours was the first name that he said.
Oh, that's amazing. Thank you.
So so definitely somebody that I feel lucky to have this presentation. So, but I just kind of was curious how you kind of see yourself in the whole situation.
Well, thanks. So I was born and raised in Hawaii, and I did spend a year away. So I got to really understand what my connection to Hawaii is. When you're away, that happens. So when I came back, I really dug in. My background is in marine ecosystems originally, but I have a master's in public administration.
Okay.
So I am somewhat suited for this work. I sort of fell into the invasive species world. I was doing education, environmental education and administration for years. With the Waikiki Aquarium, I was teaching at Hawaii Pacific University and a bunch of other things. When I started in invasive species work, I started with the Maui Invasive Species Committee. They had just started up, they got a crew, and they needed a communications person to make sure that landowners were contacted to make sure we had permission to go in yards and across properties. And so that was my first real job with invasives. Fast forward, I was offered a few years later this statewide coordinating position. I started originally only focusing on public outreach and engagement, and then took on the jobs of coordinating and policy and all of these other layers that, once you show that you understand something, they put something else on your plate. Like, oh, she understands that. Maybe we'll put this on her plate too. And so I do feel like I've got a little bit of experience now with understanding and answering some of those questions that people typically have. I do like to still feel like my perspective, though, is very much a public perspective. I try to think the way the public thinks so that I can be a better communicator. That's my gig. So, but that means I've got more than 20 years of experience trying to interpret scientists and be that liaison between science and people and policymakers and people. So,
and that's where you see gaps.
Where I see gaps, and thanks for circling me back around, because sometimes that ship has sailed and I'm like down the path and think I've answered the question. I haven't. So gaps is a group that started by the Nature Conservancy. The director was back in the mid 1990s, thinking that they had all their conservation plans and all of their plans and processes worked out, and they were going to work, and then they realized that they don't have any plans that address specifically invasive species for prevention, for anything but pulling them out of the ground once they got to their preserves. And that was kind of a wake-up moment. And one of the things that they did, and Alan Holt was that person. Alan was the director back then. He said, we need to start this interagency group because no one agency has all of those mandates. No one agency has the capacity. There's gaps between the mandates and gaps even within offices where invasive species can come through. So Coordinating Group on Alien Pest Species forms the acronym. We see the gaps and we try to fill them. And that is why I've got such a long title. Dang you, Alan. But that's okay.
See the gaps and try to fill them.
Yes.
I actually heard that.
Well, and so we've been operating for a while, and we realized that we were great at engaging mid-level managers. And that was where we really focused. But every few years we have a change of administration. We have new chairs of agencies, and there needed to be a mechanism to ensure that those leads, particularly of state agencies, were at the table. And so we helped to lobby for the Hawai'i Invasive Species Council. There was a little bit of lead up to that. It's kind of a long story, but we very much see ourselves as one part of the puzzle. HISC was a very important, still is an important part of that puzzle. HISC focuses primarily on what state agencies can do because it's a state agency with state statute and rules, and that of course doesn't apply to federal. But federal is half of the picture, which we'll talk about in our framework slide. And so CGAPS really tries to function in that spot. We really dig in with feds and making sure that the community is engaged and understands what's going on. So sometimes it feels a little repetitive. We go to HISC meetings, we go to CGAPS meetings, I hear that some of the same things, but some of them aren't the same. So, yeah.
Very good, thank you.
Yes, thanks. All right, so getting into natural history, Hawaii, the archipelago, is very remote, and the Pacific Ocean, from a islander's perspective, the Pacific Ocean connects us. From a species perspective, though, non-human species perspective, it's quite a challenge. It forms a barrier to getting to islands. And so you can see it in both ways. From a natural history perspective, it took a lot of work for species to arrive here, successfully colonize and build populations. So those folks that are not familiar, we are here, you're here. And formation of the islands is important to understand because people from other island groups across the world, sometimes they were originally attached to continents and they separated out. Sometimes they are, there was a land bridge or whatever the other processes going on. For Hawaii is quite different. We're formed through a hotspot, and that's where superheated lava or magma at that point, because it hasn't emerged, builds up and there's a hole in the plate, the Pacific plate, and then year after year that magma builds up, volcanoes emerge, and we have islands. The islands are conveyed on that plate, though, because plates are moving. They're not just hanging out steady. Our plate is moving up to the north and then up to the west at a very slow rate, about the rate of your fingernails growing, which is kind of cool to think about. We're like, oh, I got to trim my nails. Like, ooh, further north now. Yeah. And so what that means is that there's always islands being formed. They're not always connected to that stationary hotspot. But when this plate moves over that hotspot, then that gives the opportunity for new islands to form. And when you look at that globe perspective, you can see our island chain going all the way up until we've got atolls in the Papahanaumokuakea, the northwestern Hawaiian Islands. And then even further, you can see that slight turn when it really gets pulled and subducted under the Aleutian chain. Those are the Emperor Seamounts. Those used to be Hawaiian Islands. Right? Yeah. More than 70 million years ago. So some of those were in that hot spot. There were like things going on there, not people around, but that's how things are going. So that we really never had a land bridge. So of course, there were no seeds in the soil when these islands emerged, and no living reef. And every time an island emerges, that is the case. Interesting when you get into the evolution part of it. So our natural history, how did we get things here? Well, we tell kids, and we tell you now, they arrive here via the 3 W's: wind, wings, and water currents, or waves sometimes people call it. So some seeds, spores, insects, and even spiders arrived on the wind. Yeah. And anybody who's had to read Charlotte's Web knows this, right? Charlotte's Web, man, 4th grade, right? But okay, so Charlotte's Web, well, the spider's got to go up to the top of the fence post because it's time to move to a new place to have her little keiki. Same thing happens. These spiders get picked up, get carried into the jet stream, and some get deposited here. I would say even today, there could be spiders landing here on our islands. Crazy, right? Wow, there could be seeds landing here today from the jet stream and getting here via that W. A few birds flew or blown off course, and in them or stuck to their feathers were more seeds. So they arrived here on wings. And we know that actually this is probably how our snails got here, our terrestrial tree snails. There's a chat group going on. I think it was on Facebook originally, but people were just commenting about how many times they're seeing snails on birds. It's really weird. Like, you would think birds are just like, try and jettison all this weight before they cruise, but apparently it's fairly common. Some seeds floated here on ocean currents or waves, and ocean currents also carried the eggs and larval fish of invertebrates and even freshwater stream species. In the middle of this salty Pacific, in our freshwater streams at the top of the mountains, we have native freshwater fish. How the heck, right? So they are anadromous. They have a saltwater phase where somewhere in the Indo-Pacific, there's a stream. They released their eggs down into the ocean. It went out, got carried in jetties and the ocean currents. Our species had long larval stages. They were able to get here. They were able to get their way all the way to a stream mouth where the biochemical cues say, okay, this is it. Now you can turn into your adult phase and you can start seeing that transformation occur. And then they go up the stream and start that cycle again. And because we are so isolated, there is no ongoing connectivity, genetic connectivity. And you can think about that for stream species and also terrestrial species. So they get here, but no genetics leave, very few genetics leave. There's not a whole lot of input or output. So that was a long time on that one, but I love that story.
No, fascinating. I was a history major. So keep going.
Right on. All right, so I have some examples of change over time. We use the word evolution a lot, and just as a communicator, I want to shout out to one of our partners in one of the federal agencies who said, it may not seem like it, I'm very science oriented, but I'm also a fundamentalist. And that word just brings up, it immediately makes people put up walls. And so if you can just explain what change over time is, you will lower more walls that way. And so I always use this examples of change over time. Let me talk to you about the birds. Let me tell you about the birds here, kid. These are honey creepers, and they descended from original colonists. We know through genetic work, largely done by researchers at Smithsonian, that they descended from original colonists that were highly likely to be rose finches. They flew or were blown off course across from Southeast Asia between 5.2 and 7.8 million years ago. Yeah. And so you would think that, wow, that's kind of a strange thing, but rose finches have this interesting tendency in that they'll fly around in these large packs. And when it gets really crowded, there's too much competition for resources. A segment of that flying around population will just take off. They call it eruption, starting with an I, not an eruption as it's starting with an E, where they take off and they start a new founder population somewhere else. So this very likely was the thing that was able to get enough birds to Hawaii with enough genetic diversity in enough numbers so that, you get here, you better hope you bring a mate. Better hope you're capable. Better hope you find food and good resources. So that characteristic probably allowed all of these to arise after landing on our islands and slowly spreading out over generations and generations, eating the different foods because there was almost no competition. There were no predators, and just allowed this flourishing. Incremental changes over time due to diverse habitats, diverse foods, and the relative isolation of individual islands. And if you noted the timing, the arrival of these birds meant that they likely arrived when Oahu was where the Big Island is today. Yeah. And as they moved out to different islands, you can have speciation that way. And then they can sometimes move back and you can have additional speciation. So just amazing that they can get all of this through genetic work. So
fascinating too about the eating different foods.
Yeah, you are what you eat, right? And you have the tools to eat what you need to eat.
Yeah, there's a factor in their evolution. I just never really thought about eating food.
Yeah. Yep. So yeah, we think Darwin, if Darwin would have got to Hawaii before he got to the Galapagos, maybe he would never have come to that same conclusion because our honey creepers don't look enough alike. You would assume that they're different species. I mean, different original colonist species. So when you look at the curved bill of the EEV and the curved flower of the Trematolobelia, of which there's about 125 different species that arrived tens of millions of years ago and changed into different species over time. And you look at the perfect fit of that EEV bill into the Trematolobelia, and you can see it's getting a little bit of pollen dabbed on its head. So you know what pollinates this species. That's change over time. It's not change just based on food. It's also co-evolution, co-changes over time. So I ask students when I talk to them, I love this question, what curved first? Right? It's like a chicken and the egg question. What curved first? The bird's bill or the flower? And you can actually Google rosefinch and see what the original bill looks like, or very likely looked like. Another change over time, Hawaii has native mint. And when the ancestors arrived, there were no ungulates because pigs don't fly. They're very bad at riding currents, things like that. And so there were no predators, no effective predators of mints here. And so why produce a minty flavor, which is its defense, if you don't need it. So put all your energy towards what you need to be able to grow and thrive, and maybe tone down those genes that produce mint. And that's what happened. We have a mintless mint, and you can see what the curved flower looks like, and you know what pollinates it. So for anybody with the marine environment that's joined out, yeah, right on. Here's a marine example. This is a tiger cowrie, and the native range of tiger cowries go all the way to West Africa coast, all the way throughout the Indo-Pacific. All of the Australia has them, Coral Triangle, but almost everywhere else in the world, even though oceans are connected, almost everywhere else in the world, tiger cowries get to be about 3 inches. In Hawaii, they get to be about 6. Why is that? Well, we don't know. But this gigantism is one of those factors of when the tiger cowries rode those currents over, they couldn't continue to breed or exchange genetics with that source population. There weren't new genetics coming in. That's how infrequent it was. And so the genetics of our tiger cowries enabled it so that we have larger tiger cowries here. We don't know why, though. More better, more food, who knows? Maybe we don't have the predators, all of the effective predators of tiger cowries. I have no idea. And so a summary slide for natural history, a whole bunch of years, isolation, millions of years, time change over time. We have nearly 20,000 native species. And I always include the definition when I tell people, what is a native species? Because I hate to get to my point and somebody says, well, what really is a native? So these are plants and animals that arrived at a location without the help of people or our conveyances or as the result of our actions, and all of the descendants from those colonists. And when you think about it, this can then also include what we're doing for climate change. The climate is changing due to the results of our action, and that is allowing species to move into different areas. It is the results of our actions. So I'm a big tent type of person, so I'm like, oh, that fits totally. I can see it. And so moving forward on a timeline, Polynesians arrived and they brought the first non-native species. Non-native is the word we use. We don't use aliens anymore. That's got different connotations. So let's move out of that. Non-native is species that are transported or are living in a new habitat as the result of people or our actions or conveyances. And some of the things that Polynesians brought when they arrived, they brought taro, coconut, kukui, chickens, dogs, geckos, Polynesian pigs, and Polynesian rats. I love to point out the gecko thing because, all right, come on, they did not pack their geckos, right? And who can exclude geckos from anything? Container ships and all of that. They were probably a best example of a hitchhiking species. And in fact, across the Pacific, our brown house geckos that are ubiquitous on all islands, they've actually evolved a trait to be able to manage the fact that they may find themselves conveyed on a boat and on an island without a mate. They are able to produce, it's not clones, but they're able to produce young using their own. They don't ever have to meet up with a male. It is not egg storage. It is not sperm storage. They're able to produce young with genetic diversity, even without ever having been in contact with males. And that's how these geckos are so successful on islands. Wow. Right? I know, like mind blowing. You tell kids this, they're like, what? Yep. And so, when you look on your screen at night, you got the porch light on, and you see these brown house geckos, almost always think about 2 eggs there.
Almost always what?
They have 2 eggs in them. Yep. So anyhow, they also brought the first invasive species, though. Polynesians did. And these are those non-native species whose introduction causes or is likely to cause harm. to all sorts of everything, right? Everything we're concerned about, including us. So making a distinction, not all non-native species are bad, but concerned about invasives. Moving forward on our timeline, Western contact, that's just 245 years ago that Captain Cook landed. And almost immediately we got in a whole bunch of new species. One great example, I love to point this one out, is goats. Captain Vancouver told King Kamehameha, I brought you a present. And King says, wow, that's great. And he's like, look, goats. And he's like, whoa, those are good. And he said, I put a kapu, and I don't mean any disrespect to the king. I just, I love the thought process translated to modern day. He says, I'm putting a kapu on these. We're going to let them run all over the place. These are good things. Nobody touch them. This is a photo of the goats. I think this photo is from 1950. Same descended from Captain Vancouver's present. This is on the Kona coast. And even today, if you were to cruise around on the Kona coast, you can just count the number of goats. You're like, thank you, Captain Vancouver, the gift that keeps giving. And so this and a lot of other things were released. Mosquitoes were brought for the first time in barrels of drinking water on whaling vessels. And so the first recordings of mosquitoes were in Lahaina, which is the whaling port back then. And very soon we got some diseases, and of course the diseases that are transmitted by mosquitoes, not just bird malaria, but also human diseases. There have been introduction of human malaria and other mosquito-borne diseases of people that were wiped out pretty quickly back then by the Hawaii Territorial Health Department. All right, moving forward today, 1.4 million residents and 9+ million visitors per year. And what does this mean? Lots of opportunity for things to come in. So we never had any land reptiles. So like snakes and lizards and tortoises. We never really had any freshwater reptiles. So like soft-shell tortoises, turtles, and things like that. And now we've got at least 40. We never had any amphibians. Amphibians being bad at saltwater, number one, terrible at riding birds, and not so good at riding here on logs. Now we have at least 6 different ones, including coqui frogs. We know we have at least 20 insects established per year, but there was a study done at the Kahului, the Maui airport, called the Kahului Airport Risk Assessment, or CARA. And they just super staffed the airport for a few weeks, I think it was like 6-week term. And they opened and looked in all of the air cargo and air passenger spaces coming in, and found an average of 1 new that is not known to occur in Hawaii, insect or plant disease arriving per day at an airport that receives less than 2% of incoming air cargo. You can imagine what's going on down at Honolulu Harbor, where we get all of the big container ships, all of the air cargo. Some other statistics, we have documented at Bishop Museum at least 10,000 plants that have been introduced. There's a reason for that. Not just people want them. Not all of them have become established, but we know a significant number have established and are causing true ecosystem harm. For marine and brackish water species, we've got at least 421 now. Now, if that's bumming you out, I hear you, man, I'm bummed out too. But when you look at the terrestrial spaces that have functional native ecosystems left, that's about 50% remaining. I'm a glass half full type of person. When you look at the marine spaces, it is way higher than that. If you want to see 90% native species, go snorkeling almost anywhere. Most of what you'll see will be native. So we've got more than glass half full. And if you think about any other place, let's think of England. They've had thousands of years of invasion by a whole bunch of different people moving different things around. They hardly know it's native, but we do. And we know it. and we can identify, we know it's native and what's not. We know where they are. And so that's a real opportunity in my mind. So again, I hate to get to this spot. Are all of the aliens bad? Should we just like try and keep everything out? No, absolutely not. But we should definitely focus on invasives. And of course, that invasive species definition is not just in, it's not just my definition, it's actually set in a federal executive order. So there's that. All right, so here we go. Oh, my rose appears in the wrong. All right, well, sorry, ignore the rows on the second 2, 3 columns there. Focus your attention, folks, on the left screen, the world's biota. Now, for plants alone, there's at least 300,000, I mean, God, who knows how many plants are out there. For insect species, there's like ucubillion. It's a technical term. So the world's biota is out there, right? And how do we keep them from coming here? Well, our first barrier is going to be pre-entry. And so what our options are, well, we can do nothing. I mean, honestly, sometimes it's hard to do things and it's costly. We have to figure out what we can do. And we can set up laws and agreements to try and keep some of these things out. International laws and agreements are things like the World Trade Organization has mechanisms where you can potentially keep things out or keep things in everybody's individual. Everybody keep their own species except for the trade things. And for the ocean part, that's the International Maritime Organization, the IMO. So those are the two primary like world level groups. We also have federal and state regulations that can keep things out. Kind of cool.
Can I jump in really quick?
Yeah.
Sorry.
No.
The IMO, that is just the
International Maritime Organization.
It's voluntary to comply with it?
No, it's actually not. So the International Maritime Organization sets up binding agreements. I'll use a ballast water one as an example. So everybody agreed that ballast water was a problem. It was spreading invasive species around, and vessel operators had to do something to manage their ballast water. So at the IMO, they set up a ballast water convention. And that doesn't mean a meeting. That simply means a binding agreement. And they work to get different countries to sign on. Now, the US is not a signatory to the Ballast Water Convention, but that doesn't mean that our vessels don't have to comply. Anywhere they go, if they cross over and want to land in another port, they need to comply. Wow. So even though we have not signed on, it is a binding agreement, and it actually drives some of what we do in the US, because vessels will need to go across the ocean. Like, we need to go from California to, Asia to move goods. And so why don't we have a US federal standard that aligns with the IMO standard? So in that way, you can influence things from the bottom up or from the top down. And the IMO, the Ballast Water Convention, is a great example of that. Good question. So let's say you don't set up great things, or some things aren't kept out, and that's totally normal. So our second barrier is going to be the port of entry barrier, that second wall. And that's inspection and port monitoring. And this is done by federal agencies, so USDA, Customs and Border Protection, as primary agencies for invasive related things. And you can also have state set up inspections, and we have Hawai'i Department of Health that looks at domestic imports. The feds look at foreign imports into the US. State looks at domestic imports, so shared things going on there. One of the challenges, and here's a gap for you, we see the gap, the federal list of things to watch for is not the same as the state things to watch for. So if you wanted to import something and it is on a state restricted list. You can't bring it in from domestic. You could potentially, and please don't do this, you can potentially send it to your friend in somewhere else outside of the US,
Wow.
right? And have them send it to Hawaii. And honestly, the reverse happens all the time too, where things get shipped from foreign, they enter into California, Long Beach is a main station, and then they get transshipped to Hawaii. So, I mean, it's interesting that things can get missed in a variety of different ways. Now, not just to poke at feds for not having the same list as us. You know, our list is pretty restrictive. On the state side, we don't have enough people, resources, capacity. We don't have the technology. We're just a little bit undergunned here. And so I don't know what's better. I think we need to do better in both areas. So anyhow, that's inspection. Monitoring, we also need to monitor and detect around ports of entry. And this means like on the grounds of the airports and seaports and anywhere they open containers. Containers just kind of get moved straight from the ports. I mean, they get railroaded across wherever. They get picked up and put onto a ship. The ship comes over, they get put onto a truck, they get opened wherever they're going. And they're not allowed to open that container. So whatever was in it, a skunk, gets opened in Hilo, and then Auntie's got to catch it with a piece of teriyaki chicken. True story. So we need to make sure we have that in place. When that doesn't work, then of course you have some escapes. And what are our systems there? Well, we need to try and do early detection, rapid response. This is where our invasive species committees come in, our state agencies, Department of Ag has some capacity there. But we have this framework of stopgap measures that have been put in place. And thank heavens the ISCs are there now and can assist with some of these things that are coming through. We need more of it. We need to make sure we're able to back them when some crazy new thing comes in and they need to drop what they're doing to pick up something else. Our other option is, of course, regional containment. We can try and contain it to that island it is on. There's problems there, of course. So
escapes are common?
Escapes are common. Oh. Absolutely. When I cited that number 20 insects per year become established, that's because they escaped. Okay? And plants, they escape all the time, I would say. So when they escape, they
insects per year become established. Sorry,
right?
that didn't sink in. Or
no, it doesn't until you go through some of these. Yeah, and you know, in public, in communications, we say you got to hear it 3 times. So we got one more time to.
Yeah, that one I got. That one's a scary one. Wow.
Yeah. So when they do escape or we're not able to contain it for whatever reason, we found it too late, it flies and you can't eradicate it, whatever the case is. If it is widespread, or it came in years ago and we didn't do anything then and it's widespread, we have options again. We can do nothing, which is what we do a lot of the times. I mean, it's too widespread. There's nothing we can do. Wash hands. We can protect high value areas. Hey, gosh, nice shirt. We can do biocontrol or things to reduce damage. So how do we reunite it with that one predator or parasite that can knock back its population enough so that it's not causing as much damage? What are some of those other tools we can use to mitigate damage? Because we're never going to get rid of it. We can do mitigation to preserve some of that function. And then, are there new technologies? I think that's a space that we can look in, and Walbaki is a great example of that. So that's our framework. That's our protection system. I'll circle back around to where I think we need to focus, but let me use some of these examples and noting the time. So what are our priority issues? There's tons to choose from. I'll just go pick 5. So mosquitoes and all of the diseases they vector. we know about the mosquitoes that came in. They're carrying bird malaria and other diseases. As the climate warms, we're seeing bird habitat, which is now at the very tops of the mountains, because mosquitoes, these species of mosquitoes don't breed up there in that climate. Because the climate is changing, it is warming, it is becoming more available to mosquitoes. And so the birds are losing their habitat because the mosquitoes are now able to transmit this disease. So we see this as a problem. It is definitely a problem. We get new mosquito species on occasion, and we could very likely someday get the mosquito species that can carry the malaria, human malaria virus.
Oh.
We should learn how to take care of mosquitoes better before that happens. And so, I've got this little icon down at the bottom. There are new technologies that make it feasible, finally, for us to try to manage this situation. That's a great thing. Continue to work on that. Invasive plants, a lot of folks on the line right now are working on invasive plants. These things like Miconia, found grass, strawberry guava is so widespread that there is no way you can manage it. And these are causing not just harm to biodiversity, but they're harming ecosystem function. They're reducing the amount of water that goes in the watershed. They are making the forest less resilient. They are capturing less carbon, capturing and holding. And then fountain grass, burn, baby, burn. As Mike Walker said, and I love he said this, we don't have a fire problem. We don't have a wildfire problem. We have a fuel problem. Wow, man, drop Mike. Thanks, Mike. And so what are some of our solutions to that? Well, there's a couple of them. The weed risk assessment system was developed a long time ago. Like all of 20 years ago. But it's used very successfully. It can flag 95% of those invasive plants that are going to be invasive here. We should use it. Another solution is biocontrol. Everybody talks about, well, we can't do anything about it. No, a lot of plants, and in fact, even some insect pests can be managed by biocontrol. We just need the capacity to dig in and do it. Rapid ohia death, we don't have a whole lot of great solutions for this. Fungal pathogen, we don't know its origin, probably arrived here a couple of times because we have 2 different species of this pathogen. We have the very aggressive leuco-ohia, and the one that we think has been here longer, the Julio-ohia. There's no known cure for the situation. There's no way we're going to get rid of this. And so how do we future plan for always having this? Well, continue to work on all of the things that we do, and that is understand it, work on ways that it spreads, keep people from spreading it. And then now we have to work on how do we work on making the forest where it is currently spreading, making it more, at least keep its ecosystem function into the future. How do we do that? And that's going to be a huge task. Here's one that I've been working on a bit lately, stony coral tissue loss, or scuttled. It's a disease of coral that is not known to be present in Hawaii. It is present in Florida, where it was discovered in 2014. It has since spread to all of the Caribbean island countries, and in fact to South America and a variety of other reefs in the area. It is deadly to coral. It kills it affects more than 26 species of coral. It kills them dead as a doornail very quickly. So it's like the rod of the coral world, except it affects more than just one species, right? The challenge is that we don't know the agent yet. It has not been isolated, so we can't test for it. And the other problem is that it can be spread long distance in ballast water. This is the water that vessels take up to stabilize it. You remember first slide, I pointed out that connectivity via the Panama Canal to this region. Super scary. Ballast water treatment, which is mandated by the IMO, is only 50% effective at killing the pathogen. So, all right, half of it's dead, but half of it's alive. We're coming to Hawaii. It can also spread in other ways. So it is a problem. I think the only high point is that it's a priority for agencies. All right, not everybody knows about it in Hawaii. I think it's been very quiet here. But DLNR does know about it. Emergency rules are being prepared and reviewed by the AG to stop ships from discharging ballast water in Hawaii. Ships from that region, not all ships. All right, my number one is got to be hitchhiking pests. You know, what's out there that we don't know? And most things arrive on imported commercial commodities, on plants, produce, cut flowers, livestock, aquaculture, all of these things that we import. And I love this Newsweek article. Bugs on a plane, United flight infested with ants spilling out from bag in overhead compartment, heebie-jeebie, goosebumpy, get me a gin, gross. Get me a gin, gross. Yeah, that was a direct quote. I'm like, yeah. So some things arrive in packing materials, in the container, in the fuselage, all of that, cargo hold. Some things arrived in containers of household goods. And remember, those just get moved from the ship to the house site. And you got to get her trapped with teriyaki chicken ready. And then I'm going to include biofouling in this. This is the stuff that grows on the wetted portions, the outsides of the vessels. Those are hitchhiking. The only good news we have on this is, all right, we've got some good plans. We've got some plans. We know what we need to do. They're documented in the interagency biosecurity plan. It's a priority on the Aloha Plus challenge that all of the mayors and the governor is signed on to. We should be aligned. We just need to do it. Nike was right. Oh, and that was it, actually. If anybody didn't understand ballast water, I had a little graphic for you, but I'm going to stop sharing. Stop share. All right. So now is the time. We got about 10 minutes. I'm sorry I talked so much. If anybody has any questions or anything like that, we can certainly go back. Mike, yeah, you're on iPhone. I saw you there. Yeah, it was you, dude. I was on that meeting. Clay may have said it first about the wildfire being a fuel problem, but shout out to you for saying it at the right time. I think with so many people on the line. Yeah. Jack's got his notes ready. He's going to ask a question.
Oh, yeah.
Okay.
I got three. But
yeah, well, go ahead.
Okay, so the first one was something that we had mentioned. You guys mentioned it a couple of weeks ago. I'm blanking on the name, so forgive me. But that old report from 2002 that assessed the
legislative
filling.
reference.
Yeah. So Jack is asking about a report called Filling the Gaps. It was a Legislative Reference Bureau report that documented the need to set up this. This was the year prior to HISC legislation. Go ahead.
And the fund. Remember the one that had to do with, is that the same report that had to do with it's not the funding, but how much is spent on invasive species? It was like
was it a 20?
Well, I thought it was 2002.
It might have been the same report, yeah, where it does have a funding section, like how much we're spending on invasive species.
Okay.
Yeah.
Yes.
Okay. Yeah, that was the focus. Sorry.
Yeah.
Yeah. And so just what were your thoughts on that? Is it outdated?
Yeah. So the questions about, there were two Legislative Reference Bureau studies that were done. First one is in 2002 called Filling the Gaps. And they cited some numbers. First of all, that we need to spend 50 million more to address invasive species. And this was actually a CGAPS number where we got together and had a retreat and just talked through about what we would need to be able to address a few key species like we did. What would you need to be able to adequately address myconia, mosquitoes, aquatic, I can't remember what the aquatic invasive species was. And so we used a variety of taxa species and taxa to talk through this. And that actually added up to, wow, we shared. So some of these functions could be shared, and we didn't want to double count. So through that exercise, we got 50 million. That was reported in that. That study also, along with the more recent 2017, can't see the forest for the albizia trees, in air quotes, but that's in the title. Also did a follow-up study with agencies. How much do you spend is the question. And that's really a difficult question to ask, because, I mean, Chelsea, well, actually, Mike, is your job wildfire, or is it invasive species? What portion of your money is invasive species, and what should conceivably go under wildfire? So when you have these big surveys like that, you're asking people to really try and figure out how much is being spent. I think asking the question, how much do we need to spend, in addition to what we're already doing, is the more valuable question. All right. Other questions?
Yes. The second one was, you had talked about the first gap that you found between the state and the federal. The list of species didn't match up, and so that seems I don't know what species they are, but it seems kind of frustrating. I would imagine that this is a problem. I was just wondering if you could go into more detail about all of that, and what are you, hopefully there are things that can be done. I'm sure you're working on it.
The challenge is really understanding how the federal agency sets its quote list, or how it sets its criteria. In any of their websites, they are the agency that protects the value of American agriculture for trade. So they want to make sure that they have tradable commodities and feed American people with American products. But so when they're looking for pests, they're looking for pests of soybeans and potatoes. And those things that really don't resonate with us here. We're concerned about a whole bunch of different things, and we're never going to get them to see that as a priority, because they set federal policies for the nation, not individual states.
And so the federal, it's all Department of Agriculture. That's is there a different department that maybe would be more interested in instead of just protecting American?
They are the primary because of international agreements. The World Trade Organization, the International Plant Protection, the organization, they call the trade partners to the table, and they set what different nations are going to do related to pests. So because USDA is the party at the table for that, we're never going to be able to have Department of Interior, who's concerned about maybe other pests of cultural issues. They're never going to have a seat at the table to be able to do that. So it's a functional challenge to make sure that the agents, that we have some way of communicating what the priorities are. And I'm going to just say that islands need to do this together, that we need to band together and ask for additional things, because our needs are never going to be met. So, that's just a short bit of it. We can go on and on. You want to talk about a long time, I can talk an hour, but maybe your last question would be.
Another time, but it seems like there was a lot to talk about there. But I was just kind of curious. We had talked about biocontrol before, and I was kind of curious. It just seems, I don't know, it seems like an amazing opportunity. Maybe it's more efficient. I don't know. In the long run, it would be great to go out and, send in crews in the field to do work, but it seems like biocontrol long range long-term
Yeah.
is the way to go. And I don't know if that's how I don't know if it's there yet. I don't know. Just kind of curious your thoughts.
Yeah, Hawaii has a really long history of biocontrol, successful biocontrol, but they've also had a bunch of a series of unfortunate incidents that have really driven public opinion. And it's not just Hawaii, but worldwide. Unfortunately, biocontrol was really going pretty strong for a while worldwide. And it hit kind of a wall a little bit in the last, I'd say, 15 or 20 years. And so everybody has been doing a little bit less biocontrol. I think we are on the upswing again, particularly with a couple of recent reports that really dug into the data and showed that risk is significantly smaller. I mean, orders of magnitude smaller than what people are thinking or what is even in recent memory, because of the protocols that are in place now. And so I think there is a great opportunity with biocontrol, but there's also a great demand. We alone have dozens of species that could really use some biocontrol. I mean, dozens is really probably maybe saying it lightly, undercounting, honestly. So relying on that we still need to do prevention and EDRR. For the ones that are here, though, I absolutely think we need to ramp up our work.
Yeah, no, I certainly wasn't suggesting
good.
Cutting the other things. I was just saying it just seemed like something worth investing.
Absolutely.
Yeah, and making it a key pillar of it.
Yeah.
But I don't know. I'm still.
Yeah. Yeah. All right. Well, are there questions on online on Zoom? You can go ahead and unmute yourself if you'd like, or comments.
Hey, Christy, great presentation. I was wondering, I was not aware of the two reports that you were mentioning. It would be great if at some point if you can circulate those around, especially the one I think I found the 2002, but I am not able to find the 2017 you were talking about. I think it will be great.
Sure.
I can send to our email list.
Yeah, what I'll do is I will add the links to the PowerPoint presentation, PDF it, and share that.
Yeah, that would be great. Thank you.
Other questions or comments? All right. Well, seeing none, let's go ahead and wrap up. I understand that this is being recorded really for future training purposes, and other folks that couldn't be here, they thought it might be a resource for people to use in the future. That's certainly the case. Happy to do it. But if anybody has questions in the future, now or in the future, future me would be very happy to answer them or talk to you. You can reach me. Use my Hawaii.edu one's probably the easiest, christym@hawaii.edu. So right on. Thank you so much for all of the work you guys do in the, hey, Dustin. Thank you for all the work you guys do in the field and elsewhere. It is a whole network of people working together. And I certainly wouldn't be able to be a talking head if I didn't know everybody was out there doing work as well. So yeah, thank you.
Thank you, Christy. That was a great presentation. It's stuff that I think some of us are pretty familiar with, but it's always good to see. I appreciate it.
All right. All right, gonna stop recording. See you guys.